Alright, warm-up number 51 is on the screen, and it reads, number 1, compute the sum difference in product of 1 plus 5i and 3 minus 4i. Number 2, it says solve x squared minus 4x minus 6 equals y. Number 3 says graph f of x equals x squared without a table. Then write the rule and graph using the vertex for the transformation given g of x equals af of 1 over bx minus h plus k, and the parameters given a equals 1, b equals 1, h equals 5, and k equals negative 7. And number 4, solve the system using substitution. The system given, one equation is y equals 2x plus 3, and the other one is y equals x minus 2. I'll give you time to do that. Copy and go. Alright, let's see. Number 1, the sum. What'd you get for the sum? About Juliana. What'd you get for the sum? What? Okay, so if we combine 4 plus I. Hands if you got that. Okay, good. How about the difference? Pass someone, Juliana?
Carlos.
Carlos, what'd you get for the difference? Negative 2 plus 9i. Hands if you got that. That is correct. Okay. Product. Pass someone. Carlos. Noor, what'd you get for the product? 23. Michael Jordan? 23 plus what? Plus 11i. Hands if you got that. That is correct. Now, you got to remember that at the end, once you do the multiplication, anytime you see an I squared, you need to substitute what number? Negative 1. So let me show you really quick what we're talking about. So 1 times 3, that's 3. 1 times negative 4i is negative 4i. 5i times 3, that's 15i. And 5i times negative 4i, that's negative 20i squared. And we said that anytime you see an I squared, we are going to substitute a negative 1 there. So if I combine stuff, let's see, I'm going to bring down the 3. Combine this, that's 11i. Negative 20 times negative 1, that's positive 20. And of course, this plus this is this, and 11i squared. 11i, sorry. All right, number 2. Let's see. How about Mr. Q? All right, I'll go over it. Now, the reason I'm going over this one because there was one very similar on the pop party the other day, right? Let's see. First thing we do is set it equal to 0. X squared minus 4x minus 6 equal to 0. From there, the very first thing that you think of is to factor. Let's see. Negative 6 and negative 4. What two numbers multiplied give me negative 6 that when you add them give us negative 4? Let's see. 1 times 6. 2 times 3. Is there anything else? No. Any of those that you add or subtract to give us negative 4? No. So you can't use factoring. But what's another method I can use? Completing the square or quadratic formula. I'm going to use completing the square. So that means I need to add 6 to each side. I end up with x squared minus 4x, empty space, equals to 6. How do I complete the square right here, guys? So we add negative 4 over 2 squared, and we do that to each side. So this is x squared minus 4x plus 4 equals 6 plus 4. What is 6 plus 4? That's 10. I still have x squared minus 4x plus 4. Okay. Next, I need to factor. Carlos, what is the shortcut to factor this one if I completed the square? Yeah, square root of the first, square root of the last, x, 2, sine of the middle, and write it squared. Yes. And from there, to cancel this squared, we need to do what? Square root, and do that to both sides. I end up with x minus 2 equals plus minus square root of 10. For right now, I'm not going to find the decimal equivalent. I'm going to leave it like that for right now. And last but not least, what do I do to solve for x? I add 2, x equals 2 plus minus square root of 10. So I write my two equations. X sub 1 is 2. What else? Plus square root of 10. And x sub 2 is 2 minus square root of 10. Now, could I find an estimate for what a square root of 10 is? Yes, 3 point something, yeah. And then I just add that to 2 and whatever that is. Okay? Woo! Let's go. So all is good, yeah? All is good. Number 3. Number 3. For number 3, it says graph without a table. Now, by now, I'm giving you plenty of practice with these because we're about to move on to the next concepts, and we need this skill. Here we go. So I'm going to graph my parabola because it's the x squared, yes? So x squared looks like this through the point of origin, and it's a parabola. There it is. And that's my what? F of x. Okay. So they're asking me to write a rule using these parameters, and it looks like a is 1, b is 1, h is 5, and k is negative 7. But we know that 1 and 1 over 1 is 1. We don't write the 1, so then that means I'm going to rewrite this down here. G of x equals f of x minus 5, and it's a quadratic, minus 7. So that's my rule. So according to this rule, tell your neighbor what's going to happen to this parabola. What's going to happen to that parabola? Alright, Rachel, what's going to happen? 5 to the right and down. That is correct. Or in other words, my vertex, or my new vertex, would be what, Philip?
5, negative 7.
5, negative 7. That is correct. 5, negative 7. So my new vertex will be somewhere down here. And our new parabola would be down here, and we'll label that what? G of x. Pretty simple, yes? Yes, nice and cute. All right. Let's move on. Number 4. Let's see. By now, your neighbor should know how to do this. Tell your neighbor what we need to do here, and if they're done, to show you what they got, please. All right, so it looks like y is what? All of this. So on my second equation, instead of writing y, I'm going to substitute 2x plus 3, yes? 2x plus 3, and all that equal to x minus 2, and then we solve. So minus x, we got x plus 3 equals negative 2, then minus 3, x equals negative 5. That goes right here. Am I done? No. I need to solve for y now. Which equation do you want to use, Brooke? The top or the bottom? The bottom, okay. So I write y equals x minus 2. However, instead of x, what am I going to write, guys? Negative 5. So I bring everything else down. Y equals negative 7. So aside from being the solution, tell your neighbor what this is. Tell your neighbor what that is. What is that? All right. What is that, Lois? Very close. He said the y-intercept. Very close. Let me show you what it is, just in case you didn't get it. Here it goes. I'm going to graph the first equation, y equals 2x plus 3. Here's 3 right there, and that one is going to look something like this. Yes? So far so good? All right, next. I'm going to graph the second one in blue, and it starts where? At -2. -2 is down here, and that one's going to look something like that. Okay, well, guess what? This point should be that. What is it? -5, -7, something like that. So what is that point that we find at the end of the solution where both graphs intersect? Okay. All right. Agenda for today, warm-up number 51. Today we're moving on to complex numbers. It's still within the same umbrella of the quadratic equations. And we're going to be doing some stuff with complex, so I need to clarify. I noticed I introduced this on day 1. Man, thinking back, it was a fun day, right? Everybody was in shock that I gave you guys some home play on day 1. You're like, what? Oh, yes. Fun stuff. So today we're moving on to complex numbers, and your home play for tonight, pages 133, 134 only. And once again, you can get that on Canvas, or if you copy the Nearpod code correctly, you can go to Nearpod and get it right there. Right, guys? Yeah? All right. Here goes your Nearpod code. QU8C3. QU8C3. Alright, and by the way, do you guys notice I put batteries on my marquee over there?
Yeah.
Hashtag do your home play. Let's go. Alright. So, what was your home play for last night? It said, focus on your notebook and binder. Right? Act like a meadow. So if I right now said, you know what, give me your binders, because I'm going to check them overnight, will that be your 25% of your overall grade for the semester? Some of you are like, yes, I'm ready. Some of you are like, oh snap. Oh snap is right, so you get it ready, please. Please. And once again, home play for tonight, page 133, 134. Let's move on. All right, here we go. Get a Cornell note ready. You do need a Ferrier model today. Today, I just want to clarify what complex numbers are, and we're going to be working with those. All right? Yes, Mr. Q? All right, good. Our objective for today, I can define and compute complex numbers. I can define and compute complex numbers. I can define and compute complex numbers. What's our concept for today? Complex numbers, very good. Good participation from everyone. Appreciate it. Are you guys all right? It's Tuesday, guys. Come on. Let's go. Yeah, it's already Tuesday. Let's go. Already. And then we have Wednesday tomorrow, and then we have a day off on Thursday? Come on now.
It's kind of weird.
Isn't it?
Yeah.
Yeah.
This is like the first time.
Right, no school on Thursday, yeah. In college they didn't have school yesterday? Okay. Alright, so, what are complex numbers? Here we go in your Ferrier model. Complex numbers are numbers that contain one real number and one imaginary number. Numbers that contain one real number and one imaginary number. Examples: 5 plus 3i, 12 minus 6i, 2i, and square root of -8. Copy that and all of that. Alright, here we go. So, according to the definition, complex numbers are numbers, and they contain what? One real number and one imaginary number. So obviously, if we look at these examples, let me go with the first one, 5 plus 3i. The 3i is my what? Imaginary, which means what? The 5 is my real number, okay? Look at this one. My real number is 12. What is my imaginary? -6i, okay? Here goes a tricky one though. Look up to the screen. My imaginary is 2i. Tell your neighbor the real number for that complex. Talk it over to your neighbor. What would be the real number? Alright. Audrina, what is my real number? Very good. Plus 0, because there's no number there. Yes? Alright. Question. What is this number? Talk it over here. What would be this number? Is it a real number or is it imaginary? Correct answer. Imaginary. Why? Because whenever you have a square root of a negative number, it's imaginary. So whatever that number is, this is my imaginary, which means tell your neighbor what would be our real number. What is our real number? Since it doesn't have one, then it has to be what? 0. That is correct. Okay, copy the non-examples. Here we go. Actually, before you copy them, look up. Tell your neighbor what's so obvious that these are not complex numbers. What is the obvious thing that makes them not complex? Let's see. Alexa, why are those not complex? Doesn't have an imaginary, therefore what would be our first hashtag, everyone? Imaginary. Yes. What else? Hashtag what? Real plus imaginary. Nice and neat like mine, yes? Okay. Alright. Enough tomfoolery, let's move on. Yes, example number 1. Copy this one. It says identify the real and the imaginary number. This is just to clarify, to make sure we understand what we're looking at. Okay? Now for real numbers, I'm going to use the color blue. And for imaginary, I'm going to use the color red. Now the symbol for real numbers, look up. From now on, whenever you're talking about real numbers, I want you to use the letter R, but with 2 bars down. That's the symbol for real numbers. And of course, the symbol for imaginary is the letter I. So, let's see. Example 1. They give us the complex number 7 plus 3i. Raymond, what's our real number? 7. And what's our imaginary? 3i. Thank you very much. Hands if you agree with that. Okay. Let's move on to the next one. Copy this. Example 1Q. 5 minus 2i. 5 minus 2i. Once again, the letter R with double bar for real. The letter I for imaginary. Alright, tell your neighbor the real and the imaginary for that complex piece. Alright. Miguel, real. 5. About our imaginary. Negative 2i. Very good. Thank you. Alright, let's do another one. Here we go. Example 1, super cute. Negative 5i. Negative 5i. Identify the real and the imaginary. Alright, tell your neighbor the real and tell your neighbor the imaginary for that complex. Alright, let's see. Real number. Sandra, what did you get for your real? 0. And for your imaginary? Negative 5i. Hands if you got that. Alright, and one last one. Copy this one. Example 1 mega cube, 7i. By now you should be an expert at this, yes? Alright, tell your neighbor you're real, tell your neighbor you're imaginary. Alright, Saul, real. Imaginary? Alright. Hands if you got that. From 1 to 5, how comfortable are you with these? Okay, that's part 1 of your home plate. Okay, let's move on to the second part. Copy this. Example 2, it says find the sum difference in product of 2x plus 5 and x minus 3. We need to find all three things. Have we been doing that on the warm-ups? Yes, Mr. Q. Alright, good. For the sum, I'm going to use the color blue. For the difference, I'm going to use the color red. And for the product, I'm going to use the color green. Just keep organized. So let's start with the sum. Plus. So we end up with 2x plus 5 plus x minus 3. So just to reiterate on this, is there anything outside of the parentheses that we need to distribute? No. So that means we ignore the parentheses and just combine. What is 2x plus 1x? That's 3x. What is 5 and negative 3? That gives us positive 2. And that's our sum. Let's go to difference. Subtraction. So we got 2x plus 5 minus x minus 3. Do we have something to distribute now? Yes, that negative needs to distribute into this parentheses to both terms. That leaves us with negative x and positive 3. Now we can combine. What is 2x and a negative x? That's 1x. Next, what is 5 plus 3? 8. And that's our difference. Go to product. We have 2x plus 5 times x minus 3. Alright, what method do you want to use? Vertical, area model, distributed property? Distributed property, alright, so I'm going to start with my first term. 2x times x, that's 2x squared. 2x times negative 3, that's negative 6x. Then I got positive 5 times x, that's positive 5x. Positive 5 times negative 3, that's negative 15. Can I combine stuff? Yes, right here, Mr. Q. What is negative 6x plus 5x? That's negative 1x. Bring down the negative 15 and bring down the 2x squared. And this is my product. From 1 to 5, how comfortable are you with these? Yeah, right. 5. You guys throw me off every time I'm turning 5, and all of a sudden somebody's like, 1. Anyways. Alright, so we got this. Let's see if you can get one by yourself. Copy this one, example 2Q. 7y minus 2 and 5y plus 4. Also find me the sum, difference, and product of those. I'll give you some time. Copy and go. Sum. Noor. 12y plus 2. Hands if you got that. Looks about right. Pass someone. What'd you get for the difference, Brianna? What is it? You haven't finished? Oh, help her out. Bree. 2y minus 6. 2y minus 6. Hands if you got that. Looks about right. Pass someone.
35y squared plus 18y minus 8.
35y squared plus 18y minus 8. Hands if you got that. Yeah, we got this, yes? We got it, right? Alright. How about this one? Not too easy. Copy this one. Example 2 super cube. Let's see how you do with that one. Oh, yes. as Yoda said, use the Force, Luke. Just follow the process. It's fairly simple. You'll see how it works. I'll give you some time for that. Example 2 super Q gives us AX plus C and BX plus C. Copy. Alright. Get this show on the road. Let's see, who haven't we been called on for a while? Who? Oh, Sky. What'd you get for the sum, Sky? AX plus BX plus 2C. Hands if you got that? That is correct. And here it is. AX cannot be combined with BX, so we just write them out. However, what is C plus C? 2C. Do you see what we're looking at? Okay. How about the difference? Christian, what'd you get for the difference? Help him out, Andrew. AX minus BX. Hands if you got that. Yes. Why? Because we distribute the negative here, and the positive C and the negative C, they cancel, and we're just left with AX and minus BX. So here goes a fun one. Product. What'd you get for the product? Andy. ABX squared plus C squared plus ABCX. What else? Plus BXC. Okay. Not in that order, but I got something similar. ABX squared plus ACX plus BCX plus C squared. Now, if you got anything similar to that, you're good. Now, if we were to write them in standard form, then we would need to move them around a little bit, but other than that, there it is. And if you got something like that, yeah, we got it, yeah? All right, so from 1 to 5, how comfortable are you with these? Yeah, 4, 5, 4, 5, 4, 5, yeah. That's the second part of the home plate. So let's move on to complex numbers, yes? Complex numbers, here we go. We got example 3, write this down. Find the sum, difference, and product of 5 plus 7i and negative 2 plus 9i. So, we've been doing these on the warm-up, yes? Yes, Mr. Q. All right, good. So I'll give you some time for this one. Find me the sum, difference, and product of those two. Copy and... All right. Let's see what we got. What'd you get for our sum? Let's see. Lenny, what'd you get for the sum? 3 plus 16i. Hands if you got that. Looks about right. And here's the work on the screen. All right. Lenny, pass someone. Miguel, what'd you get for the difference? I? Oh, I didn't get it. Okay. Help him out. Saul. 7 minus 2i. Hands if you got that. And there's the work on the screen. Product. Pass someone, Saul. Brooke, what you get for the product?
I don't know if I did it right, but I got 53 plus 69.
53?
Yeah.
Okay, close. It's actually 70. And we'll get there, watch. So look up, here's distribution. Let me combine stuff. Let's see where I'm at. I got negative 10, Combine 45I and negative 14, that gives us what? 31. 31I plus 63I squared. However, am I done? No, what do I need to substitute, guys? Instead of I squared, what do I write? Negative 1. So whenever you see an I squared, I substitute negative 1. So what is negative 1 times 63? That's negative 63. And now I can combine. What is negative 10 and negative 63? That's negative 73, and bring down the 31I. Hands, have you got that? Some of you? Okay. Who forgot the last step? Show me your hands. Who forgot the last step? All right, so do me a favor. Put a little asterisk here in the heart. And write, don't forget, please, 10Q. What? Oh, happy face? What? It's right there. Oh, my bad. Forget. There it is. So please, pretty please, from 1 to 5, how comfortable do you feel with these? Yeah, 5, 4, 5. Yeah, we've been working on these on the warm-up, so guess what? That's the third part of your home plate. All right? However, today, I'm going to introduce you guys to one more portion that's not going to be part of your home plate, but I want to get a step up for tomorrow. And it's on electronic circuits. So write your utensils down, look up to the screen. I'm going to introduce you to a basic electric circuit. Ready? Here he goes. Here's my basic electric circuit. Here's the light bulb. You guys see it right here?
That's a light bulb?
Yeah, it's well, it's because the light's turned off right now. Be nice. And my battery's right here. And here's a switch. So if I was to tap down on that switch, guess what's going to happen here on the light bulb? It's going to turn on. Now, let me show you a basic circuit that we use every day. Noor, can you do me a favor, turn on the left switch? All right, so look, he turned on that switch. What lights came on? These two. That's a basic circuit. Switch, power, we get it from the electricity instead of the battery, and there's my light. Well, here we have at least two circuits, because if I turn on the other switch, guess what? It's going to turn on what? The other three. That's another circuit. Do we have more circuits? Yes. When you plug in your devices on the wall, that's another circuit, and so on and so forth. Now, let me show you this. Let's say you guys were in my company. I start a company on electric circuits, and we're going to sell this. And I have you guys packing stuff, and you need to include instructions. Now, if we take a picture with color, it's too expensive. With color, costs money. So I would have you draw a diagram. Look at the diagram. Do you see the switch? Lamp, battery. What are these here that make the little box? The wires. That is correct. So next time when you see diagrams, you're like, oh, Mr. Q showed me that this is a wire. Right? Not just a box. Now let me show you more elaborate circuits. This, and this, and that. All that, guys, these are on TVs. These are on your cell phones. Believe it or not, back in what was the year that the man from the U.S. landed on the moon? 60 what? 69 or 68? 69, right? Back then, picture this. Picture a huge rocket taking off from the U.S. Lands on the moon, comes back. That technology now you have in your pockets. It's in a cell phone. All that they were able to advance so much, and now it's compressed in that. And it has all these components. Today I'm going to introduce you to 3 components that we're going to be working with and doing mathematics with. Here they go. Copy this table, please. Electric circuits. Electric circuits. The first one is known, and on the it's going to be a two-column table. On the left column, you're going to label it circuit component. On the right side, symbol in circuit diagram. So here we go. The first component, known as a resistor. The resistor, the symbol looks like this. It's like a little wire with a zigzag. Now, an easy way to remember that, hopefully some of you have helped around the house to change a light bulb. Has anybody changed a light bulb before? Okay. But when you change a light bulb, you're going to see that the reason that they go out because they have a little wire that burns. That wire looks like that when it's not burned. When it gets... what's that? It's a little filament that is created, and it's so thin that it gets so hot, that's what it creates the light. But with time, it wears out. Here goes the next one. The next one is known as an inductor. Inductor. Now, let me see if I can turn on the camera in here so I can show those that are watching online. Oh, yes, here it is. So I'm going to create, can you guys see me there? Yes? All right. I'm going to create an inductor right now using this wire and this pencil. Watch. What are you doing, Mr. Keel? All I'm doing is winding a wire around the pencil. But if I was to put this in an electronic format, this will be made out of metal as well as this wire. Now, an easy way to remember these, some of you have seen houses that they have like a little knob or a switch that turns on the light very slowly. Have you noticed that? It's the same idea with this. If I was to take out this metal rod, as soon as I take it out, it starts dimming the light, and if I put it back in, it starts bringing the light back. It creates a magnetic field. Now, those of you that want to do an experiment at home, get a nail from the garage, get a wire, and wind it like this, and connect the battery, and guess what? You create a magnet. That's why it's called a magnetic field. So this is known as an inductor. So watch, look at the symbol that it creates. Do you see this coil right here? That's the symbol for inductor. Write that down. That's the symbol for inductor. That's where we get that symbol. And the last one that we're going to talk about is known as a capacitor. Capacitor. Now, hopefully by now, some of you have seen vehicles that when they lock the vehicle with a little remote, what happens to the lights? Beep, boop, they flash, right? So that tells you that, you turn on the lock system and it locks the car. However, check this out. There's a little brain inside of the vehicle for the alarm that does that. It sends out a quick signal of energy to the lights to go like this. But have you ever thought about, probably not, but when it's evening, people turn on their lights, that sends energy to the lights, is that correct? Wouldn't that send energy back into the brain of the alarm? Yes, right? However, there's something stopping it from sending more energy into the brain. That's known as a capacitor. It allows the energy to flow in one direction but not to come back. That's why the symbol is like this. It stops the energy from coming back in the opposite direction. It allows it to flow, but it stops it like this. And this is the symbol. It looks like two hands going like this, stopping it. So, tomorrow we're going to be doing some math using this. We're still not done. I need you to copy one more diagram just to make sure we got the three of them. What are the three? Resistor, there's the symbol. Inductor, there's the symbol. And capacitor, there's the symbol. We need to get used to these symbols, so watch. Copy this diagram. Example 4, without looking at your table, once you copy it, label the name for each component. Label the name for this one, for this one, and for this one. So, name for this one is resistor. That is correct. How about for this one down here? Capacitor. Yeah, because it stops the energy from returning back the opposite direction. How about this one? Inductor. Fairly simple? Okay? So watch. Don't copy this next one, but let me show you how these start becoming more elaborate. Look up to the screen. All right? Look up. Tell your neighbor the name for this one, please. Inductor, that is correct. How about this one? Capacitor, and of course this one's our what? Resistor. Let me show you another one. Look up to the screen. All right, point to it, tell your neighbor all the names of those, please, really quick, before we close this up. All right, Brooke, what is this one right here? Inductor, yes. How about this one, Raymond? Capacitor and resistors. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Tutoring today after school. Be there or be elsewhere. Bye.